All right, on page 28, question 6, we're given this diagram, and we're told the backyard, shown in the diagram on the right, is shaped like a rectangle that is twice as long as it is wide. The patio, whose area is 36 meters squared, occupies 1/8 of the total area of the yard. The small base and the height of the trapezoid corresponding to the garden are each equal to half the width of the lot. The large base of the trapezoid, which corresponds to the garden, is half the length of the yard. What is the area of the garden? There's a whole lot of information given to us in those sentences that we can actually translate and mark on this diagram. Let's start with the first sentence. A backyard, shown in the diagram, is shaped like a rectangle that is twice as long as it is wide. So in this case, we're talking about the overall shape of this rectangle. That represents the backyard. The question tells us that this dimension of the backyard is represented by the letter Y. That sentence that I just read says it is shaped like a rectangle that is twice as long as it is wide. Given we know that the width is represented by our letter Y, we could say that the length could be represented thusly. We can say that if this half of the rectangle and this half of the rectangle, this side of the rectangle here is twice as long as this side, and we know that this side is a Y, we know that we've got a Y here and another Y here. And if we add those Y together, Y plus Y, that will tell us how long this side is. And that is actually represented by 2Y. So I can write that down. Let's take a look at the next sentence. The patio, which is here, whose area is 36 meters squared. I can write that down. I can say area equals 36 meters squared. Let's go back to the sentences. Occupies 1/8 of the total area of the yard. So the total area of the yard, we can make a note. We can say this area is 8 times 36 meters squared, since we know that 36 meters squared is 1/8 of the overall area. So that tells me the area of the overall rectangle. The small base and the height of the trapezoid corresponding to the garden, so they're talking about this shape here, from there down, across, up, and then across the top. So this trapezoid here. The small base and the height of the trapezoid corresponding to the garden are each equal to half the width of the lot. So that means this dimension here and this dimension here are congruent. So these sides, this side and this side, are congruent, and they are also half the size of this dimension, which is represented as the letter Y. So we could say this side is 1/2 Y, and this side is 1/2 Y. Let's continue reading. The large base of the trapezoid, which corresponds to the garden, is half the length of the yard. So they're saying this side here, the large base of the trapezoid, is half the length of the whole yard. This whole yard length is 2Y. So the dimension up here is half of 2Y, which we can write as Y, because half of 2 is 1. So this dimension is Y. Now the question says, what is the area of the garden? So let's take a look at the formula for area of a trapezoid and then plug in the numbers that we know. So let's look at the area of a trapezoid formula. And we can find that on page 22 in the workbook. And it tells us that the area of a trapezoid is equal to the large base plus the small base multiplied by the height, and that is all divided by 2. So we can write that as an algebraic expression. We can say the area of the garden is equal to the large base, so we'll use uppercase B, plus lowercase b, which is the small base. We add those together, then we multiply by the height, and we divide that whole number by 2. Let's take a look at the dimensions that we know in terms of our variable y. We know that the size of the large base is equal to y, and the small base is equal to half a y. So we can substitute those numbers in. We can say this is the same thing as y plus 1/2 y. And then if we go back, we can see our height is equal to 1/2 y as well. And that is multiplied by 1/2 y, all divided by 2. The next thing we may want to know is how big y is. So instead of writing 8 times 36 meters squared, I can perform that calculation. And if I know that 8 times 36 is equal to 288, I could say the area of the rectangle is equal to 288. But we know 2 other things about this rectangle. We know that the long side is equal to 2y, and the short side is equal to y. So let's use the formula for the area of the rectangle. We can say the area of a rectangle is equal to length times width. From our diagram, we have 2y and y as our length and our width. So we can say the area is equal to 2y times y. If we multiply 2 times y, we could say that's actually equal to 2y squared. Now the nice thing is, we know the formula for the area of this rectangle. If it has a short side with the distance y, our area is going to be 2y squared, and that's going to give us 288 meters squared. So we know that information. We can say 288 is equal to 2y squared. Now we need to simplify this algebraic expression. So let's think about how we can simplify this expression. The first step in my strategy is to try and get the variable by itself. So I have 2y squared. There's no constant on this side, which means we're not going to add or subtract anything to this side. But we do have some operations that we want to undo. This is actually 2 times y times y. And we can undo one of those operations pretty easily. If we divide both sides of the equation by 2, that will give us something simpler. So let's write it out and see what we get. I'm going to write this long form so that it makes a lot of sense. So we've got 2 times y divided by 2 is equal to 288 divided by 2. Our rules of algebra say that we're allowed to do the same operation to both sides, since it does not change the relationship between the left and the right side. And the nice thing about 2 times y is that multiplication is commutative, which means we can reorganize any of these terms in order and it won't affect the quantity. That tells me that y times 2 divided by 2 is equal to, this is a calculation, I can simply perform that calculation and simplify. 288 divided by 2 is 144. And on the left side, I have y times y is equal to, on the left side, I have y times 2 divided by 2. The result of 2 divided by 2 is 1. Y times 1 is actually just equal to y times y, which is just equal to y squared. So let's say y squared is equal to 144. Now I have an operator that I can undo. The opposite of a squaring operation is to square root. So I could say the square root of the left side is equal to the square root of the right side. And the square root of y squared, or the square root of y times y, is just the variable by itself. So that's y. And the square root of 144 has 2 solutions. It has 12 or negative 12. And I can say it's plus or minus 12. That's our algebraic simplification of the equation that we were given. Now let's go back to our original problem. Back to the original question. Now that we know the values that satisfy the mathematical equation we were given, we can put those onto our diagram. And here's the very important part of this problem. Mathematically, we had an answer of y is equal to positive 12 or y is equal to negative 12. But in the real world, and on this diagram, shapes cannot have a side length that's less than 0. That simply doesn't exist. That means that y in this diagram is not negative 12, it's just positive 12. Now that I know the value of y, I can say this is 12 meters, and this side is 24 meters. But I can also make my life a little easier by using our value of 12 into this equation here, which was what we calculated for the area of the garden. So let's do that on our next page. Our formula for the area of the trapezoid in terms of y is this algebraic expression. Now that we know the value of y, we can substitute that in. So I can write 12 plus 1/2 of 12 times 1/2 of 12, and that whole thing is divided by 2. This is now something that we can simplify because we know 12 plus 1/2 of 12 is the same as 12 plus 6. Multiplied by 1/2 of 12 is 6. And that is all divided by 2. So let's simplify the top a little bit more. 12 plus 6 gives us 18. And using our calculator, we can say 18 times 6 is 108. So I'm going to say that is 108 divided by 2. And performing that operation tells us y. When y is 12, the area of our trapezoid is 54 meters squared.